Okay, today is your lucky day because today you're going to learn how to rearrange an equation from standard form to vertex form. So standard form is the form that you've been looking at right before you factor it. So the quadratic, the linear, and the constant term are all on one side of the equation, and you've got either 0 or you've got y on the other side of the equation. We're going to rearrange it into vertex form, which is what you looked at in the first unit of quadratics, where you're able to pick out the h and the k to get the vertex. So remember that the h of the vertex is the x-coordinate, and it's the opposite sign to what it looks like, and the k is the y-coordinate of the vertex. So taking an equation from standard form and putting it into vertex form is a little bit tricky at first, but I guarantee, well, I hope to guarantee, that with practice, you will be able to do it. And a lot of people actually find that this is one of the skills that they do very well on the test. But you have to practice and you have to study it. It's complicated at first, but with practice you will get it. So here we go. We're going to take this equation and we're going to put it into vertex form using 5 simple or complicated steps, whichever way you want to look at it. So the first thing is to common factor the coefficient of the quadratic term from the first two terms. Do not factor out the x. So that means from the first two terms, you're going to factor out the 2, not the x. So the 2 goes on the outside, that becomes your a value, and on the inside you have x squared plus 2x. That negative 3 is going to stay on the outside. So factoring means we're going to divide both of those by 2. So it's starting to look like factored form already. That is not the k value, but that will start to form the k value, but that is definitely the a value. So that's the first step. The second step is we have to take the coefficient of the linear term, which is this right here. We have to take that number, we have to divide it by 2, and it's always by 2. So this number is not always a 2, but this number is always a 2. And then what we're going to do is we're going to square the number. So 2 divided by 2 is 1, and then 1 squared is equal to 1. After we've gone through the first example, I'll go through why we're doing each step. The third step is to take this number and put it into this brackets right here. Y equals 2 bracket x squared plus 2x. Now we're going to add it and we're going to subtract it. And that minus 3 is still out there. Once again, I want to go through the whole example before I explain why we're doing what we do. So that number we just found, you're going to put it into the bracket by adding it and subtracting it. The next step is we're going to take this number here that you subtracted and multiply it with the a value. So basically we're going to use the distributive law on that term only. So 2 times negative 1 is negative 2, so it's going to come out of the bracket and join that negative 3. So the a is still going to be out front. Inside the bracket we're now going to have x squared plus 2x plus 1. The negative 1 gets multiplied by the 2 and joins the negative 3 on the outside. And when those two get joined, negative 3 minus 2 is negative 5. last step is to factor this trinomial. So what are the two numbers that multiply to give you 1 and add to give you 2? Both numbers are 1 and 1. And because both of them are the same, remember that that means you write x plus 1 squared, and there's your vertex form. There's your a, there's your h, and there's your k. A is 2, h is -1, k is -5. So your vertex is -1, -5. So now what I'm going to do is I'm going to explain why we've done each step. In order to make it look like that vertex form, we need this bracket to be squared. So we need what is called a perfect square trinomial. This expression here is a perfect square trinomial. A perfect square trinomial would give you the two factors that are exactly the same. And the only way to do that is to take that linear term, divide it by 2, and square it. So the 2 divided by 2 is 1. The 1 squared is 1. So we need that 1 to make that perfect square trinomial. The problem is if we just add a 1, you can't just take an equation and add 1 because then that's going to change the equation. So what we do is after we add 1, we subtract the 1 because then essentially 1 plus 1, what you've done is you've added 0, so you haven't really changed anything. So that's why we had to subtract 1. But we don't really want this -1 inside the bracket because we only want this 1 to do the factoring. So that's why we have to take it to the outside of the bracket. So that's where all of this comes from. I'm going to do another example with you, and then you're going to have some time to practice on your own. So here's another one. We're going to common factor the coefficient of the quadratic term from the first two terms. So from the first two terms, we're going to factor out the -5. So you've got -5 on the outside, and on the inside we have x squared minus 4x. Remember that it's minus because it's a positive divided by a negative. You always take out whatever that a value is. Even if it ends up meaning you get a decimal here, that's fine. Whatever that number is, you take it out, even if it means giving a decimal there. Second step is we have to take this -4, divide it by 2, and square it. -4 divided by 2 is -2, and -2 squared is 4. So that 4 gets added and subtracted inside that bracket. So it gets added and subtracted. So remember, you need this 4 to make the perfect square trinomial, so we want to get rid of this -4. So this -4 gets multiplied with the a value because we're using the distributive law on that term only, and you're going to multiply them together. -5 times -4 is +20. That will come out to the outside of the bracket and join the -16. And -16 plus 20 is equal to 4. And last step is to factor. So what multiplies to +4 and adds to -4? Remember, both of the numbers have to be the same, and both of those numbers have to be -2 and -2 in this case. So this would be x minus 2 squared, and on the outside you have plus 4. So the vertex is, there's your H, there's your K, so your vertex is at 2, 4. So that is how you rearrange from standard form into vertex form. If there's any of those steps that you don't understand, make sure you mark it and ask your teacher on the next day. Now, you would only do this if the question asks, but what I want you to do is to have some practice. Once it's in vertex form, now finding the zeros. So some questions you are just asked to figure out what the vertex is, so you find the vertex and you're done. But some questions from that, you're asked to find the zeros. So in that case, you would substitute 0 in for y, and use SAMDEB, if you remember SAMDEB, to isolate the x. So the first thing we do is remove the k value. So we're going to add 5 to both sides. So that means we have 5 equals 2x plus 1 squared. Alright, next step is to remove the a. So the a is being multiplied, so we're going to divide both sides by 2. And that will give you 2.5 equals x plus 1 squared. Next step is to square root, and remember when you square root, you've got the positive square root and you've got the negative square root. So the square root of 2.5 is 1.58 is equal to x plus 1, or negative 1.58 is equal to x plus 1. And the last step is to remove what was in the bracket, which is the h. So you're going to subtract 1 from both sides in both equations. So that means 1.58 minus 1 is 0.58, and negative 1.58 minus 1 is negative 2.58. So those are approximately where your two zeros are. Now out of the entire unit, using SAMDEB to take vertex form to find the zeros is probably the least important. So if using SAMDEB over here to find the zeros is confusing to you, you really don't need to worry about it, because you could always go back up here and get the zeros from the standard form using the quadratic formula. SAMDEB just gives you an alternate way to find the zeros once it's already in vertex form, because some people would rather do this than use the quadratic formula. So what you're going to do is finish the second example using SAMDEB to find the zeros, and then you're going to do example 3, 4, 5, and 6 to rearrange into vertex form from standard form, and then once it's in vertex form, use SAMDEB to get the zeros. After that, you can press play on the video to check your answers. So please press pause now and try examples 3, 4, 5, and 6, and the second half of example 2. Press pause now. Alright, so here's the SAMDEB of part 2. Press pause to watch for longer. Here is example 3 and 4. Press pause at any time so that you can look longer at the answer. And then 5 and 6. And then the SAMDEB part. Alright, so make any markings and ask your teacher tomorrow if you had any problems. Goodbye.